Welcome to the next lecture of the linear homogeneous partial differential equation. In the last lecture we have seen that what is a linear homogeneous partial differential equation of nth order with constant coefficient, and we had seen that the solution of such equations is given by the complementary function in finding out the particular integral. So in the last lecture we had already seen how we can find out the complementary function just by writing the auxiliary equation of the given partial differential equation. To write the auxiliary equation, we can replace d by m and d dash by 1 and just finding out the solution. Depending upon the types of roots, there are two cases. One, when the roots are distinct, m1 and m2, the complementary function is given by this. You can refer the previous video. And if the roots are equal, then the complementary function is given by this function. And we had already discussed one example. We have already discussed two examples on how to find out the complementary function. So if you wish to recall it, you can refer the previous video. So today let us discuss the other part of this function, which is the finding out the particular integral. So let's talk about rules for finding particular integral. For a given partial differential equation which is of f d dash is equal to f of x comma y, the particular integral is given by 1 upon f d dash f of x comma y. So there are many cases. Let's discuss the case 1 when the right hand side of the given equation is e to the power ax plus by. Then how we can find out the particular integral? In this case, the particular integral, this is given by 1 upon f of d comma d dash, as the solution says, e to the power ax plus by. In this equation, we put d as a and d dash as b. So the pi becomes, the particular integral becomes 1 upon f of a comma b e to the power ax plus by. So it's simple. We need to replace d by a and d dash by b. Let's see an example on this. So the question is del 2z upon del x cube minus 3 del 3z del square x del y plus 4 del 3z upon del y cube is equal to e to the power x plus 2y. So we see the right hand side of the equation. This is e to the power ax plus by type. So this is case 1. To find out the solution, first we need to find out the for the solution we need to find out the complementary function plus pi. So let us find out the complementary function first. To find out the complementary function, we write the auxiliary equation. Now the auxiliary equation is given by putting d as m and d dash as 1. So let us substitute. So the above equation will become d cube minus 3 d square d dash plus 4 d dash cube is equal to 0, and into this equation we substitute d as m and d dash as 1. So this will be m cube minus 3m square plus 4 is equal to 0. Now we can factorize this equation. So on factorizing this equation, we see that we have three roots of the given equation which are given by m is equal to minus 1, 2 and 2. So the complementary function will be f1 y minus x, so this is the first root, plus f2 y plus 2x for the second root, and second and third are equal, so plus x f3 y plus 2x. So this is the complementary function. Now the second part, which is finding out the pi. So for the pi, this 1 upon f d comma d dash e to the power x plus 2y will be replaced by 1 upon f of, now here a is 1 and b is 2, e of x plus 2y. So the above equation is written by 1 upon, so this is d cube, instead of d cube we will be writing 1 cube minus 3d square, so this is minus 3 dot 1 square dot d dash, in place of d dash we need to write 2, then plus 4 d dash cube, which is 2 cube, multiplied by e to the power x plus 2y. We need to solve the denominator, so this is 1 upon 1 minus 6 plus 2 to the 4, 4 to the 8, and this is 32 dot e to the power x plus 2y. This comes to be 1 upon 1 minus 6, it's minus 5, and 32, this is 27. So 1 upon 27 e to the power x plus 2y. So we have the pi. Now the solution is given by CF plus pi. So z is equal to, first we will write CF, which is f1 y minus x plus f2 y plus 2x plus x f3 y plus 2x plus the pi, which is 1 upon 27 e to the power x plus 2y. So this is the solution. So this is the first case, and after the first case, let's go and discuss the second case. So because you can see case 2. The case 2 is whenever the right hand side of the function f x comma y is equal to sine of ax plus by or cos of ax plus by. So in this case, now the particular integral will be written by, so the pi is equal to 1 upon f of d square d dash and d dash square dot sine of ax plus b or cos of ax plus by. Here we put d square is equal to minus of a square d dash is equal to minus of ab and d dash square as minus of b square. So the pi becomes 1 upon f minus of a square minus of ab minus of b square dot sine of ax plus by, whichever, either sine of ax plus by or cos of ax plus by. So now let us see one example on this case 2. So this is the example on case 2, as we can see. So to solve this, again there are two parts. First, finding out the complementary function, and the second is finding out the PI. So first let's find out the complementary function of this given example. So to find out the complementary function, first we will convert this into d and d dash form. So let's write. So this will be d cube minus 4d square d dash plus 4d d dash square. This is equal to 0. Now we'll put d as m and d dash as 1. So this will become m cube minus 4m square plus 4m is equal to 0. So now on solving this, we can see that the roots of the given equation are 0, 2 and 2. So now the complementary function CF will be given by f1 y plus 0x plus f2 y plus 2x plus, now these two roots are equal, so this is x f3 y plus 2x. So this is the complementary function. Now finding out the second part, which is PI. So to solve the PI, this will be written in the form f of d square d dash square sine of ax plus by. So now this is 1 upon, let's write it, let's keep the d as a common d. Now this is d square minus 4d dash d plus 4d dash square dot twice sine of 3x plus 2y. Now the replacement, put d square is equal to minus of a square, which is minus of 3 square, which is 9. Then d and d dash will be replaced by minus of ab. So this is minus of 6. And d dash square is minus of b square. So this is minus of 4. This is equal to 1 upon d minus 9 minus 4 multiplied by minus of 6 plus 4 multiplied by minus of 4 dot twice of sine 3x plus 2y. So we can solve the constants down there. This is 1 upon d minus 9 minus 24. This is plus 24 minus 16. So minus of 1 upon d dot 2 sine 3x plus 2y, which is minus of 2 upon d sine 3x plus 2y, can be written as minus of 2 d inverse, which is the integral sine 3x plus 2y. So now solving, the integral of sine of 3x plus 2y will be minus of 2 upon 3 minus of cos 3x plus 2y. So we have the particular integral. Now the final solution will be given by, so let's see the final solution. The solution is complementary function plus pi. So we can see this is z is equal to, let's see what was the complementary function, f1y. So this is f1y plus f2y plus 2x plus x f3y plus 2x. Now the pi, so this is plus 2 upon 3 cos of, this is plus 2 upon 3 cos of 3x plus 2y, 3x plus 2y. So this is the solution. So this is the case 2. In the next lecture we will discuss the case 3.